Jai Hind to everyone. I am Dr. Karunesh Srivastava and I am going to discuss the fundamental facts about the light. So, first of all, what is optics? Optics is the branch of physics that studies the behavior and properties of light, including its interaction with matter and the interaction and the construction of instruments that uses or detects it. Instrumentation is the branch of engineering that mainly deals with the measurement and monitoring of the numerical equations. So, in this course we will study the nature, emission, propagation of light, generation and detection of waves. Also we will discuss different applications related to the sensing and measuring of the measurement of the light. So, in this particular lecture I am going to discuss the basic phenomena of light and theories of light. And what is the fundamental facts about the light? Light passes through the vacuum in a homogeneous medium. Light travels in a straight line. Suppose the light is traveling from one medium to another medium, light traveling from one medium to another medium, or you can say that if the light is traveling from rarer to denser medium, then it will move away from the normal, or it will come to the, or it will come close to the normal. So, in a homogeneous medium, if the light is traveling, it will go through the straight line. If light is traveling from a rarer to denser medium, then it will go away from the rarer to denser, it will come towards the normal, and if it is traveling from denser to rarer medium, then it will go away from the normal. So, light is refracted at the surface separating two transparent media. White light passing through the prism is dispersed in number of colors, and the light travels with a velocity of about 3 into 10 power 8 meter per second, and the velocity in a denser medium is less than that in a rarer medium. This is because the density of the particles in the denser medium is greater than the rarer medium. Therefore, the velocity of light is less as compared to the velocity of light is less in denser medium as compared to the rarer medium. Light bends around the corners of small obstacles and apertures. This is called the diffraction, and the light exerts the pressure. So, what is the reflection of light? The process through which the light rays falling on the surface on an object are sent back is called the reflection of light. This is just like the bouncing, throwing the ball on the wall, and it will get reflected towards the person. Thus, when light falls on the surface of an object, it sends back the light. The objects having shiny or polished surface reflects more light compared to the objects having dull or unpolished surface. So, in silver metal is the best reflector of the light. This is why plane mirror is made by the depositing the thin layer of silver metal on one side of a plane glass sheet, on a glass sheet. The silver coating is protected by a red paint. The straight line along which the light travels is called the ray of light. The straight line along which the light travels is called the ray of light. Now, regular reflection and diffusion reflection. So, basically there are two types of reflection, regular reflection and diffuse reflection. In regular reflection, a parallel beam of incident light is reflected as a parallel beam in one direction. In this case, parallel incident rays remain parallel even after reflection and go only in one direction, and it occurs from smooth surfaces like that of a plane mirror or highly polished metal surfaces. Thus, a plane mirror produces regular reflection of light. Since the angle of incidence and the angle of reflection are the same or equal, a beam of parallel rays falling on a smooth surface is reflected as a beam of parallel light rays in one direction only. And in case of diffuse reflection, a parallel beam of incident light is reflected in different directions. In this case, the parallel incident rays do not remain parallel after reflection. They are scattered in different directions, and it is also known as irregular reflection. So, we can take the example of this diffuse reflection, that a paper or cardboard, chalk, table, chair, walls and unpolished metal objects. Since the angle of incidence on such surfaces and angle of reflection are different, so the parallel rays of light falling on a rough surface go in different diffusion directions. Now, what is the law of reflection? The first most important thing is that when we incident a ray on a surface, so the important thing is that the incident ray, reflected ray and the normal to the surface of the mirror will lie on the same plane. It means you can see here, this is the plane, or you can say this is the mirror, this is the normal angle, this is the normal of the plane, and this is the incident ray. You can see here this incident ray is making the angle of I with this normal. So, when it is reflecting from the plane, reflecting from the mirror, it will make the same angle with the normal that has incident rays has been made. So, it means the angle of incidence should be equal to the angle of reflection. The angle of reflection R is equal to the angle of incidence. So, two important things are there. First is that incident ray, reflected ray and the normal to the surface of the mirror all lie on the same plane. If the planes are different, then you can't measure with the reference, you can't measure the incident angle and the reflected angle with respect to the some reference. So, for making the reference same, we have to take the plane mirror, same plane. Now, what is the law of reflection? The incident ray, reflected ray and the normal to the interference of any two given mediums all lie in the same plane. So, if I am taking, I have already told the property of the light. If the light is traveling in a homogeneous medium, then it will go to the straight line. Suppose light is traveling from medium 1 to medium 2 and the medium 1 and medium 2 both are same, then light will go in a straight line. If light is traveling from medium 1 to medium 2 and medium 1 and medium 2 both are different, then what will happen? It will depends upon the medium index, or it will depends upon the medium, that is whether the medium one is rarer or denser. If the light is traveling from the rarer medium to the denser medium, suppose this is the incident wave, the incident ray, it is making the angle of theta with the normal of the plane, and the light is traveling from the rarer medium to the denser medium. So, what will happen? It will make an angle of it will make the different angle with this normal. If this is traveling from the rarer medium to the denser medium, then this is incident ray will move towards the normal. So, it is clear that here the light is traveling from the rarer medium to the denser medium. So, this is the phenomena of refraction. So, it follows the law, Snell's law, and Snell's law states that the angle made with respect to this angle made by the incident ray with the normal is theta 1 and angle made by the refracted wave with the normal is theta 2. Then the ratio of sine of these angles, sine theta 1 and ratio of sine theta 1 and sine theta 2 is equal to eta 2 by eta 1. This is the Snell's law. Now, what is dispersion? Dispersion is basically the phenomena when we'll pass the white light through the glass prism and it will split into different spectrum of the colors, but only these 7 colors will appear after passing through the prism. So, what is the dispersion? Dispersion is when the white light passes through the glass prism, it splits into the spectrum of colors, and this process of white light splitting into the constituent colors is termed as dispersion. And when light travels from one medium to another medium, the speed of its propagation changes, and as a result it bends or it is refracted. So how we are getting these lights? So this is the phenomena of dispersion, and why these lights are appearing, only these 7 colors are appearing. This is because our eyes can detect only these colors, or you can say these frequencies and wavelengths. Therefore only these 7 colors Vibgyor, Vibgyor appears. Gyor, sorry, Vibgyor. This will appear after passing through the prism. What is diffraction of light? The diffraction refers to the apparent bending of waves around a small obstacle and the spreading out of waves past small openings. This diffraction is different. This is not totally different, but this phenomena is basically the bending of the light, bending of waves or light which is passing through the any obstacle or space between the slits. So this diffraction will be used when we will discuss about the diffraction phenomena or Fraunhofer diffraction and Fresnel diffraction on successive lectures. So I am telling you about the how diffraction occurs. I have already discussed this, and how will you find the phase difference, path difference, and the intensity of the wave when the light rays are diffracted from the slit. So we can also find the intensity of the light after diffraction. So if the opening of the slit, if we take the small example, of this diffraction. So in this single slit diffraction, you can see here the laser light is passing through a slit. This slit is having a small gap between. So this light is passing, this laser light is passing through this slit, gap between the slit, as well as will increase the width of this slit or the gap of these slits, the intensity of light will also decrease, and the diffraction phenomena, the diffraction angle will also change. So this will be different, and the maxima and minima will occur. So this maxima is known as central maxima, and other maximas are known as central or principal maxima, and other maximas and minimas are known as secondary maxima and minima. This can be found by using the simple mathematics. First of all, we will find the intensity of the light, and after finding the intensity, we can calculate the central maxima and minima. So before discussing this, we should know what is the interference and polarization. So interference is the phenomena in which two waves superimpose or superpose to form the resultant wave of the lower, higher or same amplitude. The most common seen interference is the optical interference or light interference, and this is because light waves are generated randomly by most of the sources. This means that the light waves coming out of a source do not have a constant amplitude, frequency and phase. The most common example of interference of light is the soap bubble, which reflects white color while illuminated by a light source. Now, what is the polarization? Polarization is the property of the wave that can oscillate with more than one orientation. A light wave that is vibrating in one plane is called the polarized light. A light wave that is vibrating in more than one plane is referred as unpolarized light. So what is the unpolarized light? Unpolarized light is nothing but the electromagnetic wave. In electromagnetic wave, we know that EM wave. We know that in electromagnetic wave, electric and magnetic waves are propagating perpendicular to each other. Suppose electric field is electric wave is propagating in x direction, then this magnetic field will propagate perpendicular to this, or you can say this, in y direction. So electromagnetic wave will propagate in z direction. So this is the wave that is propagating in z direction, or you can say electric and magnetic field, electric and magnetic waves are transverse in nature. So transverse in nature means they are perpendicular to each other, and the resultant is electromagnetic wave is perpendicular to both E and H. So here we have passed this electromagnetic wave, or you can say this, the wave propagating in the z direction is passed through this slit, having has been divided into number of lines, shining lines. So when we will pass this electromagnetic wave through this slit, what will happen? It will pass, this polarized glass will pass only the vertical, or you can say this is the y axis. So the wave which is propagating in y direction. So you will get the polarized wave which is propagating only in y direction. Suppose if I am passing this electromagnetic wave through this slit, then what will happen? This will pass only that component of the electromagnetic wave which is having only x component. So you will get the only x direction wave. How? Basically there are three types of polarization. So depending upon the orientation of electric field, polarized light can be divided into three types: linear polarization, circular polarization, elliptical polarization. So how will you know whether the polarized light is linear, whether the polarization is linear polarization, circular polarization and elliptical polarization? So this can be find using the mathematical expression. As I have already told you that electric field is propagating in x direction. So I am considering the equation for electric field. Ex is equal to, we can write E is equal to E1 cos omega t Ax, or you can write Ex is equal to E1 cos omega t. So no need to write this Ax. This is self-explanatory. The wave is propagating in x direction. So I told you that the magnetic field is also propagating in perpendicular to this electric field. So what will happen? What will be the equation for this? So I am writing this. If I make that 90-degree phase shift or 90-degree phase variation with this in this phase, then we can get the magnetic field. So the same equation will become cos omega t minus, I am doing some changes, I am not writing here pi by 2. So this will be, this wave is propagating in x direction, this wave is propagating in y direction. We can write here, if I further expand this, cos a minus b, I can write here cos omega t cos delta plus sin omega t sin delta. And we can write this equation 1 like this: Ex by E1 is nothing but cos omega t. Similarly, you can write sin omega t is 1 minus Ex by 1 minus cos square omega t. You will get this. I will put these values in this equation 2. So what will be there? Ex by E1 is equal to cos omega t. Ey by E1 is equal to cos omega t, that is Ex by E1 cos delta plus 1 minus Ex by E1 का whole square sin delta. This was the equation 2. So we can use this equation for checking whether the waves are linearly polarized, circularly polarized, or elliptically polarized. So if solving these, after solving this equation, I am getting the standard equation of the straight line, I am getting the standard equation of the circle, I am getting the standard equation of the ellipse, then we can conclude that whether the wave is circularly polarized or linearly polarized or the elliptically polarized. So we can expand this equation by writing this Ey by E1 minus Ex by E1 cos delta whole square is equal to 1 minus Ex square upon E1 square sin square delta. So we can write here Ey square by E1 square plus Ex square by E1 square cos square delta minus 2Ex Ey by E1 square is cos delta is equal to sin square delta minus Ex square by Ey square sin square delta. If I Ey square, if I take this component to the left side, then this will become 1 and you will get Ey Ex square by E1 square plus Ey square by E1 square minus 2Ex Ey upon E1 square. We can also change the amplitude of this wave that I have taken here. Ex Ey is equal to E2. You can consider here Ey is equal to E2 also. So I can get Ey by E2, Ey by E2, Ey by E2 here, E2 square. So what will I get? Ey by E2 square, and it will be E1 square, E2 square. 2x, sorry, E1, E2. This will be 2Ex Ey by E1, E2 is equal to this will be equal to sin square 2x cos delta is equal to sin square delta. So this is the standard equation for getting the polarization behavior of the electromagnetic wave or polarization behavior of the light. So this is the, if I consider Ex is not equal to Ey and delta is equal to even multiple of pi. So even multiple, or you can start from 0, pi, 2 pi up to 2n pi. So what will be the changes in this equation? Say this is equation 3. So I will get here Ex by square by E1 square plus Ey square by E2 square. If I am taking delta is equal to 0, pi, 2 pi, the cos delta or cos values of these angles cos 0 will be equal to 1 and sin 0 this function will become 0. So what will I get? I will get here 2Ex Ey upon E1 E2 is equal to 0. Now you can see here this is nothing but Ex by E1 minus Ey by E2 whole square is equal to 0. So you can write here Ex by E1 is equal to Ey by E2. So we can write here Ey is equal to E2 by E1 Ex. This is nothing but the standard equation of for the standard linear equation y is equal to mx type. So you can see here, if I am considering Ex is not equal to Ey and phase angle is 0 pi 2 pi up to 2n pi, then we'll get the linear equation. Similarly, if I am considering the odd multiple of this angle, I mean to say this is, I am wrong here, so 0 2 pi and 2 pi. If I am considering Ex is not equal to Ey and delta is equal to pi, 3 pi, 5 pi, etc., then you will get also the same equation with the different angle. So this will also give the linear polarization. I am considering the third case, Ex is not equal to Ey and delta is equal to pi by 2, 3 pi by 2 and so on. So what will I get from here? This is the standard equation that I have written, Ex by Ex square by E1 square plus Ey square by E2 square minus 2Ex Ey by E1 E2 cos delta is equal to sin square delta. This is the same equation. So if I am considering this Ex is not equal to Ey and delta is equal to pi by 2, 3 pi by 2, 5 by 2 and so on. So what will happen? This factor will become 0. Cos pi by 2 is equal to 0. So this factor will become 0 and sin delta is equal to pi by 2 and this will give the value 1. So what will I get? I will get here Ex square by E1 square plus Ey square by E2 square is equal to 1. So this is the standard equation of the ellipse. So you can see here, if this condition is satisfied, then the polarization will be elliptical polarization. And if I am considering the same equation, if the magnitude of E1 and E2 is equal, E1 is equal to E2, then what will happen? I will get here Ex square plus Ey square is equal to E1 is E square I am considering here. So this is the standard equation of the circle. So these conditions are satisfied for getting the circular polarization, for getting the elliptical polarization, for getting the linear polarization. So we have to remember these conditions. First we have to remember this from where I have got this. So you have to consider two waves that are propagating with some angle. After getting this, we will put all these values in this equation and we will consider some special cases. So these special cases are, we are considering the angle. We are considering the angle delta phase angle even and odd multiple, magnitude is not equal. If the magnitude is equal, then we are getting the circular polarization with this angle. So this is the procedure and this is the method. How can we get mathematically the elliptical polarization, circular polarization and linear polarization? So this is all about the polarization. In the next lecture, I will discuss some more important topics that is related to the optical instrumentation and basics of optics. Thank you.